If you use a coding agent daily, you already know the 4 moments. 1. You ask for something slightly ambiguous, and instead of asking which way you meant it, the agent silently picks one and builds on that choice. You find out 20 minutes later. 2. You ask for a small function and receive an architecture, a configuration system you didn't request, an abstraction over something used exactly once, error handling for conditions that cannot occur. 3. You ask it to fix one thing, and the diff touches 9 files. Comments reworded, formatting improved, none of it wrong, exactly, none of it asked for. And 4. It tells you it's done, with total confidence, and it isn't. Those aren't your prompts being bad. They're the characteristic failure modes of this technology. They're consistent across tools and vendors, and a few days ago, Karpathy wrote them down, publicly, precisely, in a way that named things most of us only feel vaguely. And then somebody did the obvious thing that almost nobody does. They turned the complaint into a file. One file, permissively licensed free, that you drop into a project so the agent reads the diagnosis before it writes a line. That's what today is about, and I want to be clear about why it's worth 16 minutes. The file is not the interesting part. The mapping is. Somebody took a list of behavioral problems and produced a specific testable rule for each one. That translation from "this thing annoys me" to "here is the instruction that prevents it" is a skill worth having, whether or not you ever download this. 3 things. First, what Karpathy actually said, quoted exactly, because the phrasing is better than any paraphrase, and one line in it is the sharpest description of the problem I've read. Second, the 4 principles the file turns that into, each with the concrete rules underneath it. 2 of them come with a 1-sentence test you can apply to any diff, and those 2 sentences are the most portable thing in the whole repository. And third, the honest part, including a note the author wrote, limiting his own work, and the 4 observable signals that tell you whether any of this is actually helping, rather than just feeling productive. Everything today is read from the repository this morning, quoted verbatim where it matters. Let's go. What he actually said. 3 passages quoted in the file. I'm reading them as written. The first, and it's the one that names the deepest problem. The models make wrong assumptions on your behalf and just run along with them without checking. They don't manage their confusion, don't seek clarifications, don't surface inconsistencies, don't present trade-offs, don't push back when they should. Read the verbs in that list, because they're all the same verb wearing different clothes. Don't manage confusion, don't seek clarification, don't surface inconsistencies, don't present trade-offs, don't push back. Every one of those is a failure to communicate uncertainty. That's the actual defect. Not that the model is wrong, anyone can be wrong. It's that the model is wrong silently, at the same confidence level as when it's right. A junior engineer who doesn't understand your request stares at you. A colleague who disagrees says so. The model does neither. It picks and proceeds, and the first signal you get is the finished artifact. The second passage, they really like to overcomplicate code and APIs, bloat abstractions, don't clean up dead code, implement a bloated construction over 1,000 lines when 100 would do. 10 times the code. That's not a rounding error. That's a different program. And it's a systematic bias rather than random noise. These systems reach for the elaborate solution by default, consistently. And the third, which is the one that costs people the most time. They still sometimes change, remove comments in code they don't sufficiently understand as side effects even if orthogonal to the task. Orthogonal to the task. That's the phrase to keep. Changes that have nothing to do with what you asked made as a side effect, in code, the model didn't fully understand. That's the 9-file diff. And it's the most expensive failure of the 3 because you have to review all of it to find out none of it mattered. Why a file is the right response. Before the principles, 1 beat on the form, because it's the thing that makes this durable. Every one of those problems is something you could fix by typing an instruction. Ask me before you assume. Keep it simple. Only change what I asked for. Most of us have typed all 3 repeatedly in different sessions. And that's the problem, repeatedly. A correction you type is gone when the session ends. It doesn't apply to the next project, doesn't apply to your colleagues, and doesn't apply on the day you're tired and forget. A file does, it sits in the repository, it loads automatically, it applies to every session and every person on the team. And it's in version control, so it can be reviewed, improved, and argued about like any other engineering artifact. The interesting shift isn't the content, it's that a working practice became a file, which means it can be shared, forked, and improved by people who've never met, which is exactly what happened here. One person's public complaint became another person's repository within days. 4 principles for 3 complaints, and why the mapping is the skill. Before the principles themselves, look at the shape of what was done here, because it's the part worth learning. 3 passages of complaint went in, 4 principles came out, and they don't map one-to-one. The repository publishes its own mapping table, and it's worth reading as a piece of thinking rather than a summary. Think before coding addresses the first passage. Wrong assumptions, hidden confusion, missing trade-offs, Simplicity First addresses the second, overcomplication and bloated abstractions. Surgical Changes addresses the third, orthogonal edits and touching code you shouldn't. And then a fourth appears that has no corresponding complaint at all: goal-driven execution. Because it comes from a different observation entirely, not what these systems do badly, but what they do exceptionally well. That asymmetry is the interesting bit. 3 principles are defenses. 1 is an amplifier. A file made only of restrictions would produce a cautious, slow, small-minded agent, technically compliant and much less useful. The 4th principle is what stops the other 3 from being purely subtractive. That's a design instinct worth stealing, whether or not you ever open this repository. When you write rules for an agent, count how many of them are prohibitions. If they all are, you've built a cage rather than a colleague, and you'll feel it as an assistant that has stopped volunteering anything. Principle 1. Think before coding. Don't assume, don't hide confusion, surface trade-offs. 4 rules underneath it. State assumptions explicitly. If uncertain, ask rather than guess. Present multiple interpretations. Don't pick silently when ambiguity exists. Push back when warranted. If a simpler approach exists, say so. And stop when confused. Name what's unclear and ask. Notice what all 4 do. They convert a silent internal state into visible output. The model already has uncertainty. That's not something a file creates. What the file changes is whether that uncertainty reaches you. The second rule is the one I'd single out. Present multiple interpretations is stronger than ask a question, because a question can be answered badly and you're back where you started. Being shown 2 readings of your own request is different. You immediately recognize which one you meant, often discovering you hadn't decided. And the 4th rule, stop when confused, is asking for something genuinely hard. A model that stops is producing no output, and everything about how these systems are built rewards producing output. Instructing one to halt and say, "I don't understand this part," is asking it to do the least natural thing available, which is exactly why it needs to be written down rather than assumed. And there's a reason this failure is systemic rather than incidental. Worth naming because it tells you how hard the rule is working. These systems are trained heavily on being helpful and agreeable. Producing an answer is rewarded. Refusing, stalling, and saying, "I don't know what you meant" are, in almost every way these models are shaped, the losing move. So the behavior Karpathy is describing isn't a bug that slipped through. It's the predictable result of optimizing for helpfulness. An assistant tuned to be maximally useful will guess rather than interrupt, because guessing looks like help and asking looks like friction. Which means a rule telling the model to stop and ask is fighting the grain of its training. That's not an argument against the rule. It's an argument for writing it down forcefully and repeating it, because a gentle hint won't overcome a strong prior. It also explains why every serious instruction file in circulation contains some version of this same rule. Everyone converges on it because everyone hits the same wall. Principle 2. Simplicity First. Minimum code that solves the problem. Nothing speculative. The rules here are a list of refusals, and I'll read them because their bluntness is the point. No features beyond what was asked. No abstractions for single-use code. No flexibility or configurability that wasn't requested. No error handling for impossible scenarios. If 200 lines could be 50, rewrite it. Every one of those targets a specific thing you've seen. The configuration option nobody will set. The interface with one implementation. The try block catching an exception that cannot be thrown. These aren't mistakes. They're the model imitating what production code looks like, without the years of context that made those patterns necessary in the code it learned from. And then the sentence that makes this principle portable. And it's my favorite line in the file. Would a senior engineer say this is overcomplicated? If yes, simplify. That is a genuinely clever instruction, because it's a test rather than a threshold. You cannot tell a model write simple code and expect much. Simple is relative and it has no anchor. But would an experienced person reviewing this call it overcomplicated? Is a question it can actually reason about, because it has seen a great deal of code review. You're not defining simplicity, you're asking it to simulate a critic. That works far better, and you can use that sentence today in any tool with no file at all. Principle 3. Surgical changes. Touch only what you must, clean up only your own mess. This one addresses the 9-file diff, and it's the most operationally specific section. Don't improve adjacent code, comments, or formatting. Don't refactor things that aren't broken. Match existing style even if you do it differently. And the rule I like most, if you notice unrelated dead code, mention it, don't delete it. That last one is exactly right, and it's a distinction most instructions miss. You don't want the model to stop noticing things. Noticing is useful. You want it to report rather than act. Observation is free. Unrequested modification is expensive. Separating those two is the whole trick. Then a genuinely subtle rule about cleanup. Remove the imports, variables, and functions that your changes made unused. Don't remove pre-existing dead code unless asked. Think about how precise that is. It's not never delete anything, and it's not always tidy up. It's, you own the mess you created, and only that mess. If your edit orphaned a helper, that orphan is yours to remove. If a helper was already unused before you arrived, it isn't, because you don't know why it's there, and neither does the model. And the second test, which pairs with the one from Principle 2, every changed line should trace directly to the user's request. That is a review heuristic you can apply to any diff from any tool in about 10 seconds. Take a changed line, ask which part of the request produced it. If there's no answer, it shouldn't be in the diff. Those two sentences, the Senior Engineer Test and the Traceability Test, are the most transferable content in the entire repository. They fit in a text message, and they work everywhere. Principle 4, goal-driven execution, and the insight underneath it. The fourth principle is different from the others. The first three are restraints, don't assume, don't overbuild, don't wander. This one is about leverage, and it comes from a separate observation. The file quotes, LLMs are exceptionally good at looping until they meet specific goals. Don't tell it what to do, give it success criteria, and watch it go. That's the most valuable sentence in this video, and it reframes the entire relationship. Most of us use these tools imperatively do this. Now do that, change this bit, which means you're the loop, you evaluate each result, and issue the next instruction. Your attention is the bottleneck, and the model is idle between your messages. The alternative is declarative. Define what done looks like in a way the model can check itself, then let it iterate until it gets there. Now the loop is inside the machine, and you're only involved at the start and the end. The file makes that concrete with a transformation table, and the examples are excellent. Add validation becomes write tests for invalid inputs, then make them pass. Fix the bug becomes write a test that reproduces it, then make it pass. Refactor X becomes ensure tests pass before and after. Look at what changed. The left column is a task fray, the right column is a finish line the model can check without you. And that's why tests keep appearing in every serious version of this advice. It isn't testing dogma. A test is a machine-checkable definition of done, the cheapest way to hand a model a goal it can verify by itself. There's also a plan format for multi-step work, numbered steps, each with an explicit verification attached step. Then how to check the step, which means a failure is localized. You know which step broke instead of discovering the whole thing doesn't work. And the file's own summary of why this matters. Verbatim, strong success criteria let the LLM loop independently. Weak criteria make it work, require constant clarification. Vague goals don't produce vague results. They produce interruptions. Every time you're pulled back to clarify, that's a criterion you didn't specify up front. How to know it's working, and the note the author wrote against himself. Two things that raise my opinion of this repository considerably. First, it defines success observably. 4 signals, fewer unnecessary changes in diffs, fewer rewrites caused by overcomplication, clarifying questions arriving before implementation rather than after mistakes, clean, minimal pull requests with no drive-by refactoring. Every one of those is something you can see in an artifact without introspecting about whether the tool feels better. That matters, because the honest failure mode of every productivity intervention is that it changes your mood rather than your output. A checkable signal is the difference between an improvement and a placebo. And second, the trade-off note, which is the paragraph that earned my trust verbatim. These guidelines bias toward caution over speed. For trivial tasks, simple typo fixes, obvious one-liners, use judgment. Not every change needs the full rigor. The goal is reducing costly mistakes on non-trivial work, not slowing down simple tasks. That is somebody telling you when not to use his own thing, in the document designed to make you want it. And he's right. Everything in this file adds friction. Interrogation before implementation, plans with verification steps, tests before fixes. On serious work, that friction is the point. On a typo, it's ceremony, and a set of rules that makes a typo fix take 4 minutes will simply be ignored, which is worse than not having them. Getting it, and what to take if you don't. 2 install paths, a plugin installed through a marketplace command, which makes the guidelines available across all your projects at once, or the file itself pulled into a single project either as a new instruction file or appended to one you already have. It also ships a committed rule file for a second popular editor, so the same guidelines apply there. One thing to check, the install commands in the documentation point at a different owner name than the repository currently sits under. Not a problem, it's the same content and paths drift when projects move, but if a command fails, that's why. Read the current page rather than a video, including this one. And the customization advice is right. These are meant to be merged with your project's own instructions, not to replace them generic principles plus your specific rules. If you install nothing at all, take these 3. Ask the agent to state its assumptions before it builds. 1 sentence, every non-trivial task. Use the Senior Engineer Test on the result. Would an experienced reviewer call this overcomplicated? If yes, ask for it again, simpler. And convert your next task into a finish line instead of an instruction. Not fix the bug, write a test that reproduces this, then make it pass. Honest limits, 4. 1. This is one person's distillation of another person's public complaint, and both are opinions rather than findings. Well-reasoned opinions that match my experience. But nobody has measured whether these guidelines improve output quality. 2. Instruction files are not enforcement. A model can read a rule and violate it. These shift probability. They don't guarantee behavior. Expect improvement, not compliance. 3. More instructions consume context. It's a small file, so the cost is small, but add more rules is not a free action, and a bloated instruction file has its own failure mode. 4. It's designed around one tool family, with a second editor supported through a separate rule file. The principles are universal. The packaging isn't. Anywhere else, you're copying text rather than installing something. Step back, because there's a pattern worth naming. The most striking thing about this repository is how unoriginal the underlying advice is, and I mean that as praise. Ask before assuming. Prefer the simple solution. Change only what you were asked to change. Define done before you start. That is ordinary senior engineer judgment. It has been true since long before any of this technology existed, and any experienced developer would recognize every line of it. What's new is that it now has to be written down, because a human colleague absorbs those norms by osmosis, from review comments, from watching someone's senior work, from the accumulated experience of having done the wrong thing once. A model has none of that. It arrives with enormous capability and zero acculturation, every single session, and it will keep making the same category of mistake forever, unless the norm is stated explicitly in a file it reads. Which reframes what a file like this actually is. It isn't a prompt trick, it's the written form of things a team used to transmit by working together. And writing them down turns out to be valuable for the humans too, because most teams have never actually articulated them either. So the sentence to carry out. The rules were always there. They just used to live in people's heads, and now they have to live in a file, which means for the first time, they can be read, argued with, and improved. So here's my question, and I'll pin it below. What's the correction you type at your agent most often? Not the clever prompt, the repetitive complaint. Don't touch anything else. Simpler than that, ask me first, post it. Because if enough of those land in one place, we'll have the crowdsourced version of this file. And I suspect the top 5 would look remarkably similar across everyone who does this work daily. Every link, the repository, the file itself, the original post it's derived from, and the install commands is in the description. That's the standard here. The source quoted exactly rather than paraphrased, the principles explained with their own tests attached, the author's own limitation read out because it's the most trustworthy paragraph in the document, and the parts you can steal separated from the part you'd install. If you'd rather own your tools than rent them, subscribe. That's what we do every single day. I'll see you in the next one.